Hey everyone, and welcome to probability lesson number 3. So today we're going to look at theoretical probability of simple events. Okay, so simple events are going to be events that have one outcome in the end. Flipping a coin, while you can get heads or tails, it's a simple event because only one thing's going to happen at a time. Okay, so if we look at probability is the likelihood of an event occurring. Okay, so the probability that it's going to rain outside, that you're going to pick a 2 out of a deck of cards, anything like that, we're looking at the likelihood that that event is actually going to occur. Okay, the event would be picking a 2, would be flipping a heads. Those are all events. So finding probability. To write probability, we just use the letter P, and then in parentheses we write whatever event it is. Okay, so the probability of any event is going to be the number of favorable outcomes over the total number of outcomes that are possible. Okay, it's going to make a little more sense once we go into a couple of examples. So probability can be written as, we normally see it in fraction form. So it could be written as a fraction. Okay, and we know that fractions can also be written as decimals or percents. We normally see fractions and percents. You'll sometimes see decimals, but it's pretty unlikely. Most of the time we're talking about fractions and percents though. Theoretical probability is what should happen in theory. That's what we need to remember. It's in theory. So now if we talk about rolling a die, which we're going to look at, it's what should happen in theory. It doesn't mean that you're going to get each one of those numbers if you roll the die 6 times. We don't know what's going to happen, but it's what we think is going to happen based on math. So looking at this first example, find the following probabilities if you were to roll one 6-sided die, so a normal die. If we're looking at the probability of rolling a 5, so rolling a 5 is the event. The fraction, we know it's going to be number of favorable outcomes over total outcomes. How many ways can you roll a 5? Well, with one die, there's only one way. Okay, so there's one way to roll a die. How many total outcomes are there? There's 6, right? You could roll a 1, 2, 3, 4, 5, or a 6. Only one of those is a 5, and there's going to be 6 total. Now in decimal form, fraction to decimal, we just do 0.16 repeating. It's just 1 divided by 6. As a percent, if we move the decimal over twice, it's 16.6 repeating percent. So that's the probability of rolling a 5. Now if we're looking at rolling a 3 or a 4, now I'm happy if I get a 3 or a 4. Those are my favorable outcomes. That's what I want to happen. So I can roll a 3, that's one way. Roll a 4, that's one way. So that's 2 out of the 6 total outcomes. 2/6, we should know, 1/3. 1/3 in decimal form is 0.3 repeating. As a percent, 33.3 repeating percent. Okay, now the probability of rolling an even number. Okay, if we're rolling an even number, 2, 4, and 6, those are going to be the even ones. So there are 3 favorable outcomes out of the 6 total. 3/6 is 1/2. 1/2 as a decimal is 0.5. 0.5 is 50%. Next, if we're looking at the probability of rolling a number greater than 7, okay, if it's a number that's 1 through 6 that we can possibly roll, is there any possible way that I can get a number that's greater than 7? No, right? So the number of favorable outcomes, it's impossible. 0 out of 6, which is just equal to 0, which is 0 as a decimal, and it's also 0 as a percent. Now rolling a positive number. If we have a 6-sided die, are there any negative numbers? No. So all of them are positive. Now we have 6 out of 6, which is equal to 1. 1 as a decimal is just 1. And this is going to be 100%. Okay, you can't do anything but rolling a positive number. Example 2, if there's a bag containing 3 blue blocks, 4 red blocks, and 9 green blocks, find the probability of the following events in fraction form. Okay, so we're just looking at fraction form. If you want to hit pause and try these on your own, I suggest that. If not, we'll go through them together. So we have 3 blue, 4 red, and 9 green blocks. The probability of a blue. If we look, there's 3 blue blocks. So there's 3 different ways I could pull out a blue block. 3. Out of, if we add them all together, there's 3 blue, 4 red, 9 green. So we're going to have a total of 16 blocks. 3 out of 16, that doesn't simplify. That's the probability. Now we're looking at a green or red. If we look at green or red, I'm happy with either one. How many green blocks are there? There's 9. So there's going to be 9 green. How many red? 4. If I add these together, because I'm happy if I get a green or a red, I get 13 out of 16. That's the probability. Can't simplify it. The probability of a yellow. There's 3 blue, 4 red, and 9 green blocks. If you pull out a yellow, that's a magic trick, because there are 0 yellow blocks out of the 16, which is just equal to 0. So that's going to be impossible. All right, so that's a quick intro to theoretical probability, and I'll see you guys later.